Last time, we showed lots of benefits if you utilize the IBIS model in your C-Link. Unfortunately, only the IBIS model may not be enough for your service application. Therefore, you may need to understand why you cannot apply the IBIS model only before seeking other better models. As long as you are familiar with the limitations of the IBIS model in this video, we may work together to seek another enhanced behavior model in the next video. Before understanding the IBIS model limitation, we could first look at what IBIS can provide. This simple example shows that the TX buffer drives the RX buffer. Then we can see not only the TX output waveform, but also the RX input waveform after the channel. Interestingly, both the TX and RX waveform between the IBIS model and SPICE model overlap well, which is our goal and also expected. That's the beauty of the IBIS model, to produce the exact waveform of the SPICE model without sacrificing the accuracy, but also provide all the benefits like shorter simulation time, good tool capability, and high battery protection. So far so good? Yes, that might be good enough in your operating data rate. But if you keep increasing your data rate, what happens? Bingo! You should have some idea of the intersymbol interference ISI from our previous video. So let's quickly review it one more time. As the data rate is higher, the insertion loss is higher at a higher next rate frequency, and this to a serious ISI issue. Then, even if the TX output data is clean, the RX input data after the channel will be a cross-eye. Although these two eye diagrams at TX and RX side might still match well between the IBIS and SPICE model. Does this cross-eye at the RX input provide any design or verification insight to you? Remember, the goal of the link is error-free. Therefore, you must apply any of the equalization techniques to open the eye at the RX output or simpler input in your circuit design verify in the SPICE model. Unfortunately, the equalization modeling is the first gap that the simple IBIS model cannot provide. So, what do you need? Correct. We need behavior equalization modeling for TX FFE, RX CTOE, and RX DFE together to equalize the channel loss greater than the 30 dB at the next rate robustly. Unfortunately, the IBIS model can only provide the error buffer behavior without any of those digital behaviors and controls. Therefore, the equalization modeling may require a few digital model interfaces on top of the IBIS. After knowing the modeling discrepancy in the data path between the IBIS and SPICE, what else could be what we need? Think about the timing margin and high-speed images for 5 seconds. Bingo! Besides the jitter contributed by the TX buffer, the TXPL clock may also contribute to the RJ and DJ. For example, DDJ over DCD at the TX outputs, which would degrade the link timing budget. Therefore, those jitters should be verified in your SPICE model, but may not be put into the TX IBIS model directly. So we may need an algorithm that could add those TX clock jitter into the existing IBIS or other behavior model. Besides the TX clock jitter, do we need the RX jitter modeling? Right, we do need, but we probably may need more about the RX clock and data recovery behavior. Can you please recall the YJ video? To make the timing margin greater, we don't only care about the input data jitter or the output clock jitter itself. Instead, we may care about the phase error between the input data and the output clock, since the timing margin is the phase difference error between the input data and the output clock's sampling phase. Does that make sense? If yes, you should also verify this CDR behavior in your SPICE model through your design. But your customer may want to know this CDR information from your IBIS or behavior model to make sure they're comfortable that your XCDR can provide enough timing margin. Again, and unfortunately, the RX IBIS model is too simple to provide the CDR modeling either in the digital or analog interface. Alright, besides the data equalization and clock jitter tracking, what else do you need that the IBIS cannot provide? Think about the simulation time or low bit array images for 5 seconds. Yes, as we show in the second slide, the IBIS waveform overlays the SPICE waveform well owing to all the tabulate voltage current and voltage time information. But that means the IBIS can only run a few thousand bits in a reasonable time. On the other hand, we sometimes may have a very low bit array target, which requires multi-million bits to get enough statistical confidence in high sigma or big outlier. Then the IBIS model may need to be revised to achieve a very low bit array estimation, which the SPICE never achieves, and a simpler behavior model is needed. In addition to those data paths, clock paths are modeled more simply. What else do you need? Think about the protocol image for 5 seconds. Correct. Every link should talk to each other through the link's handshaking or link training properly. Therefore, both the TX and RX behavior model should support the same link training protocol. Also, the link training algorithm should either emulate what the sequence is doing, or it should apply the channel analysis to determine the optimal equalization settings of the TXFV, RxCTOE, and RxDFV to make sure the link has enough SI margin to pass the training process. Alright, I think that's all we may need from the new behavior models. So, here are the summarized images showing you why you cannot only apply the IBIS model for high-speed SerDes or any wireline C-link. First, the SI issue from the insertion loss is a big concern. Without the proper waveform or the I after the equalization, there's no way to analyze if the link has enough margin in the link budget. Therefore, even though the IBIS can provide an accurate waveform as the SPICE model at the TX output and IBIS input. That's still not enough. We may want to add TXFV, IBIS CTOE, and IBIS DFE modeling on top of the IBIS model. Second, the TX clock jitter information was not included in the TX IBIS model, and the CDR's jitter or jitter tracking behaviors were not included in the IBIS IBIS model. Therefore, that's difficult for the SI engineer to evaluate the link budget in the I width for different channel profiles. Third, the simulation time of the IBIS model is still not fast enough to evaluate a very low bit array in a multi-million bits simulation in a reasonable simulation time. Lastly, the IBIS model cannot emulate the link training process properly, so we cannot only rely on the IBIS model. Instead, let's brainstorm to seek other better behavior modeling in the next video. Thanks for watching. Before you go, if you are benefiting from those circuit images, I would love to hear your feedback, and please share your comments down below. Lastly, please share the video link with people who may be benefit from it.